Today, we're going to share one of those stories that only SpaceX can pull off, when they used bike parts, no joke, to build one of the most important components of the Dragon spacecraft that goes to the International Space Station. That's what you're gonna learn today on the Uranus Show. I'm Astreus, captain of this starship and host of the greatest intergalactic space news show. And I'll tell you all about this feat right after the intro. Because Christian Davenport, a reporter from the Washington Post, is releasing a book called Rocket Dreams, and he brought this really cool story here. So, every spacecraft that's going to dock at the space station needs a docking system. That's what allows it to get close, lock into the station, and stay connected securely for as long as it needs to. When SpaceX was developing the Dragon 2, which we now call Crew Dragon or Cargo Dragon, but it's the second version, they had to come up with a system that was safe enough to handle that docking maneuver. It's all about spatial positioning and touch, you know, at the station, so they can do this locking thing we call soft capture, all right? So, it's a system that goes in, makes a little contact, then they retract it, right? They do this locking for real with 6 specific locks, and then everything stays secure. But NASA already had a design for this, and honestly, at first glance, you knew it worked. But SpaceX didn't care about that, you know? They just ignored it and said, "We'll make our own." So they handed it over to Jared Matthews, is a 36-year-old guy who worked for almost 10 years at Jet Propulsion Lab, so he already had solid experience making this kind of system. And basically, we needed to create something that actually works, isn't super expensive, and SpaceX could produce themselves without outsourcing. That was the main issue. NASA had a design, but they'd have to send it to a third party, which would jack up the costs and make integration way harder. So we've seen a bunch of problems with parts fitting together on the space shuttle and other NASA vehicles. And what did this guy do? He went to a bike shop and bought shock absorbers from a mountain bike. Yeah? From a mountain bike. For real. It's not some high-tech, space-grade stuff or anything. Then, for the rest of what they needed, they went to a place called MCM Car. And there's this hardware store nearby, kind of like a home center, where you can go buy parts, pipes and some other simple stuff, nothing too complicated, you know? The cool thing is, they named this equipment McDocker, as a shout out to McCaster here. They put all these parts together. What's interesting is how NASA's system works for docking. It's called soft capture, where it comes close, gives a little bump, and there's even some play or movement in it. You can clearly see that it moves. It's meant to be just a first contact, okay? And it has to be flexible. Remember, the Dragon weighs 10 tons, and crashing into a $100 billion lab and messing everything up isn't something you want to do. So, yeah, they showed this model to NASA, while theirs used a bunch of actuators, motors, all kinds of electronics, and so on. SpaceX's didn't use any of that. It was a totally manual system there. It didn't have any mechanical parts. Actually, it was purely mechanical, but nothing powered or automated. Which is great. You know why? Because there's less stuff that can break, less stuff that can go wrong. So they showed this to NASA in Houston, and the NASA guys were like, "No way, seriously, they actually did that." So yeah, they presented a super simple system that could actually do the job. After all, the Dragon is part of the Falcon family. After all, part of the Falcon 9 until up to the International Space Station, and that whole trip is long and goes through a bunch of launch stresses, then the space environment, and everything else. So, the entire electronic system is ready to face some issues along the way, and they managed to get NASA to buy into this, okay? Then, after they started working more closely with the NASA folks to show hey, this is how it works, this way, that way, they realized the design was really solid. It's cool, and it ended up getting approved. There are even some clips of Jared himself testing the whole system at the SpaceX factory. The point is, you don't always need to make things super complicated, either in design or manufacturing, for them to work well. Is everything like this in the space industry? Of course not, but SpaceX has a bunch of these small cases where they decided to do things themselves, and it turned out way cheaper. This system is still used on the Dragon, and on several launches of this version of the Dragon 2. There have been over 30 launches now with this Dragon, this variant of the Dragon 2, which is used for both cargo and crew versions. Jared was really nervous and anxious on the day of Demo 1, which was when they did the first real test of this vehicle. When it reached the International Space Station, he didn't want to lose his job or his career if something went wrong with it. But it actually worked out. So SpaceX has some interesting stuff because the Falcon 9, for example, if you didn't know, over 85% of it is made in-house at SpaceX. Unlike other rockets where you buy the engine from one place, the landing legs from another, the grid fins from somewhere else, the second stage from another company, actuators from here and there. SpaceX develops a lot of these parts themselves. Sure, it's challenging, but they don't get stuck on that kind of thing. We have to do something ridiculously better than everyone else in every way. Like, take NASA for example. I joke around saying they have a guy with 6 PhDs just to make a screw. Does that mean this guy is going to make an amazing screw? Probably. Yeah, it'll be really well made. But you don't actually need a guy with 6 PhDs to do that. You can just get a young engineer who just graduated, and that's more than enough. He's knowledgeable and motivated, so he might be able to pull off this task if he gets the right guidance. For sure. What's interesting here is that Jar basically got a green light from Elon Musk to innovate. Willen himself approved the design, you know? He saw it and said, "Hey, this works, so go ahead. Let's do it." Then Willen went to convince Nazareth. They had a closed-door meeting at the Kennedy Space Center in a windowless room, kind of like a real PhD thesis defense, you know, where people are going to judge your work. And Willen explained why SPCX handles so much of the production and development of parts in-house. It's precisely to innovate faster and also to make integrations quicker, right? It's worth remembering that with the Space Shuttle, systems were made in almost every state in the US. With the Apollo program, it was literally all the states. So sometimes you'd have a guy over Alaska that was developing a system that was going to be used in Florida, and if there was a problem, the guy had to travel all the way from Alaska to Florida to fix it, you know? Because some things you just have to be there in person. Unfortunately, you can't solve everything on a computer, especially back then. Then you'd see if it worked or not, and decide whether to move forward. In SpaceX's case, if there was a problem here, the guy was on the other side of the factory. It's far, really far, but the factory is huge. But it's not like a huge difference. Thousands of kilometers, like from Alaska to Florida, or even to other states like California, and so on. So SpaceX is coming up with some really impressive stuff. It's the same with Starship, okay? In the Starship project, they've developed a whole lot of things, seriously. We even have some Starship parts here. A little numbered piece with a serial number and everything. These are parts they make, then improve on, discard, and so on. Doing other things, there are parts and vehicles that end up being discarded because of that, but it's a really fast step of evolution. It's worth remembering that the Falcon 9 is on what's called Block 5. They had the first versions, right? Like 1.0, 1.1, for full trust. Then came Block 5. And even so, Willen already said that this vehicle changed a lot of things. It was mainly made to meet the demand from Dragon. So, I wanted to know if you ever imagined a bike part ended up on a spacecraft and is still working today. Of course, they probably do. They've changed a bunch of stuff there and all, but the concept is still the same, okay? SpaceX keeps innovating, and we'll keep bringing you these updates. Drop a like and subscribe to the channel so you don't miss out on news about space launches. There's a lot of cool stories and updates you might be missing. So sending love to your heart and see you, Space Cowboy!